Hi everyone, and today in this video I'm going to show you how to solve simultaneous equations via this process called elimination. And I have two examples, and so let's jump right in and then we will see why I picked these two examples to demonstrate. Yeah, so the first example, let's go to the left. We have two equations. Usually what we do is we just label them equation 1 and equation 2. And this really helps us to refer to them and remember which equations we're talking about when we're actually solving the equations. The next step is that we actually want to make the number in front of either variable, so it could be x or it could be y, but we want to make the number in front of both equations the same. And for elimination, we actually don't need the sign to be the same. So one could be 4, the other could be negative 4, or one could be 2, the other could be negative 2. The sign doesn't have to be the same, just the number right in front of it. And so, in this case, we can see that for equation 2, it's probably easier to make x 4x by taking equation 2 and multiplying it by 4. Then what we get, taking from equation 2, we multiply the left hand side by 4, and on the right hand side we also multiply by 4. Of course, I just expand, as I know how, and this is the result. This is now, let's call this equation 3. And remember that equation 3 came from equation 2. That means we are really solving equation 3 and equation 1 now. So equation 2 became equation 3, so we don't care about it anymore. At least, when we're solving it. Okay, and so now we can see that we have a 4x here and a 4x here. So that's quite convenient. Since both of them have 4x, we can subtract one from the other. Right? Since both have 4x, so I can take 1 minus 3, equation 1 minus equation 3. And now I see that both have 4x, so the 4x's will cancel each other out. So it looks like this. On the left, this is from equation 1. I subtract away what's from the left hand side of equation 3. And of course on the right hand side I also subtract them. So when I expand, as I know how, remember a negative sign changes the positive to a negative. We can see now that positive 4x, negative 4x. So they cancel each other out, and so that helps because 2y minus 12y now is negative 10y equals to 5. And so you can say 10y equals to negative 5, perhaps this is easy, and then y equals to negative 5 over 10, y equals to negative half. We found our y. Now what we do is we can take y equals to negative half and we can substitute into any of the equations. So let's just say, let's substitute into equation 1 just because it's straightforward. So substitute y equals to negative half into 2y plus 4x equals to 9. Right, into equation 1. So 2y plus 4x equals to equals to 9. Sorry about that. Equals to 9. And so 2 times negative half equals negative 1. Plus 4x equals to 9. 4x equals to 10. And x equals to 5 over 2. And there we have it. We have x equals to 5 over 2 and y equals to negative half. Yep. And so let's look at the second example now, and then you see why I picked it. For the second example, well, how it's different from the first example is that you can see that negative 2x is here, while the coefficient for x is 1. And so we already said just now that we just need to make the number without taking into account the sign the same, right? So let me just label the equations again. In this case, let's take equation 1, multiplied by 2. Because you only want the number and not the sign to be the same. So what we get is 2 times x plus 2y equals to 2 times 4. Right? And so when we just expand, this is what we get. Equation 3. And remember now what we're solving is equation 1. Equation 1 became equation 3 now, so we really care about equation 2 and equation 3. That's what we're solving, because equation 1 became equation 3. So now let's look at equation 2 and equation 3. We have negative 2x here and positive 2x here. So actually, we don't have to subtract one from the other. We can add both up, because one of them already has a negative 2x. So you see what I mean? When we have equation 2 plus equation 3, what we get is 5y minus 2x plus 2x plus 4y equals to 1 plus 8. Just add up on both sides. And then we get 5y minus 2x plus 2x plus 4y equals to 9. And you can see that because one equation already had a negative, so when you add both up, negative 2x plus 2x, this goes to 0. What we get is 5y plus 4y equals to 9, and 9y equals to 9, y equals to 1. Of course, the final step, we can substitute y equals to 1 into any of the equations. So let's just substitute y equals to 1 into equation 3, just for the ease of it. So this is what we get. 4 times 1 equals to 8, right? Because 4y, so 4 times 1, 4y, y is 1. So we get 2x plus 4 equals to 8, 2x equals to 4, x equals to 2. Voila! So we got x equals to 2, y equals to 1, and that is our answer. So you can see that either way, as long as you make the number without taking into account the sign in front one of the variables the same, you can actually solve it, either by adding or subtracting both equations together.